All right, moving on to section 11.3. We're going to step away from the three-dimensional stuff for a little while, but we're also going to step away from the linear stuff for a little while. So what we're going to look at are systems of not necessarily linear equations with two variables. So I have on Desmos here a bunch of different equations and their graphs. One of these is a line. The blue one, second one here, is a line. But we've got parabola, we've got an ellipse, which we're going to study in chapter 12, coming up soon. We've got a y equals 1 over x, which is a type of rational equation, and we have an absolute value equation here. So let's get rid of most of these here. Let's just take two of these at a time. If you have a system of two equations, the solution set for that system is going to be the set of all coordinates for points where the graphs are going to intersect each other. So if this is our system of equations, these two equations that are shown here should have two solutions. One when x is -2 and y is 4, and another where x is 1.5 and y is 2.25. So I'm going to show you how to use algebra to solve a system like that and find those solutions analytically instead of just using technology like this. So there's lots of different scenarios that you could have. That was a situation where those two equations, that system had two solutions. Here's an example of a system of equations with these two here that has no solution. This ellipse and this line don't intersect each other at all. So if we tried to solve that algebraically, you wouldn't find any valid solutions to that. There are other situations, like for example, with the graph of 1 over x taken with this ellipse. In this case, there's 4 different solutions. Okay, so there's a lot of scenarios that can show up. You can have one solution, you can have 2 or 3 or 4, or 0. So in general, like anything can happen with the number of solutions. You just have to follow your nose, follow the algebra, and see how it pans out. I also want to mention that we're going to stick to two equations and two unknowns. If you had 3 equations, then it's possible to end up in a scenario where you have no solutions because, so for example, these 3 equations, there's no point where these 3 equations all intersect each other at the same time. So that would be no solution. However, if we replace that ellipse with this line, then it is possible for a system of 3 equations to have a solution. So those 3 equations together, they do have a solution at -2, 4. But none of these other intersection points over in this region would count as solutions because those are just 2 graphs intersecting at a time instead of all 3 at once, like it is over here. So I just kind of wanted to mention that. I think that's about it. That's the concept behind intersection points of graphs and how that relates to systems. So let's dive into some algebra.